So welcome back everyone. In this video we are going to start a new topic that is called root finding with the help of Taylor series application. So the part 1 is root of a single function. So suppose I am given f of x is equal to 0 and I want to find out the solution of this. Root finding means we want to find out the solution of f of x is equal to 0. So let us write down the first order Taylor series approximation, and that is f of x is equal to f of x naught plus x minus x naught f prime x naught. So suppose if f of x is equal to 0, which means x is the solution, then my 0 is equal to f of x naught plus x minus x naught f prime x naught. This essentially means x is equal to x naught minus f of x naught upon f prime x naught. So what we had is x is equal to x naught minus f of x naught divided by f prime x naught. This is called Newton-Raphson method. Now let us understand what does this mean. This means at each iteration we are saying that x is the solution. That means at each iteration my solution is x new, which is actually not a solution until we get the convergence. I will explain what is the meaning of convergence here, but the new solution, which is x new, will be given as x naught, which is the old solution or the guessed value, f of x old divided by f prime x old. So the conditions are that f prime x naught or f prime x old should not be equal to 0, otherwise there will be singularity problem, and we will keep doing this until we get mod f less than 10 to the power minus 4. This is my convergence criteria, and x new minus x old is less than 10 to the power minus 10. So this is my epsilon 1 error, or this is my epsilon 2. If both of these goes below 10 to the power minus 10, then we will say that the solution is converged. So what essentially we are doing, we have x new, x old, f of x old divided by f prime x old. So we will get x old. This is my step 1. We will calculate f of x old and f prime x old, and then we will calculate the x new, check for convergence, which is error 1 should be less than minus 10 and error 2 should be less than minus 10. If yes, then x new is my root. If no, then x old is my x new, and we will go to this step. So this is my algorithm. So I'll take one example of this, and the example is that I have a function that is example 1, that is f of x is equal to x to the power 4 minus 4. and I want to find the root of this. So first let us calculate what is my f prime x. That will be 4 times x cube. Now assume x naught. So I am assuming x naught as 1. At 1, what is my f of 1? That is minus 3. What is my f prime 1? That is 4. This implies x new is x1, and that is 1 minus 3 by 4. That means it becomes 1 minus 3 by 4. That means it becomes 0.75. Then since there is huge difference between 0.75 and 1, so you can keep doing it till your x new is almost equal to x old, and f of x new tending to 0, and this is how you can calculate. I have not solved it actually for x to the power 4 minus 1. I could have solved it, but I didn't solve it yet. I am giving you another example which I have solved. So that is example 2, which is f of x is equal to x square minus 4. And what is f of prime x is equal to 2x. So I am guessing x naught is equal to 1. This implies f of x is equal to minus 3, and f prime x naught is 2. F prime x naught is 2. That means my x new will become x old minus f of x old divided by f prime x old, which is let me give you this: 1 minus 3 by 2, 1 plus 3 by 2, that becomes 2.5. So if I do this, then let us write down that x old, x new. So if I take x old 1, then x new will become 2.5. In the next iteration, this 2.5 will become x old, and my next will become 2.05, and then 2.05, then this will become 2.006, 09756. And if I take this 2.006099756, the next value will become 2.0000927. And if I take this 2.0000927, then my next value will become 2.0000002. So essentially this is my solution, and this is approaching to 2. So if we directly solve this, f of x will become x square minus 4 is equal to 0. Then x is plus minus root 4, then x is plus minus 2. So 2 is one root which I am calculating here. If I would have taken x is equal to minus 1, then it is close to minus 2, so my solution will approach to minus 2. So if there are multiple roots, then the guessed value is close to whatever root, that root will be found by this Newton-Raphson method. So in the next video, we will see that how this Taylor series can be used to find the root of multiple functions, or I would say the root of system of equations. Thank you.